Hey everyone! So if you're an engineer, you've definitely heard the buzzword Industry 4.0. But what does it actually mean, for your job, your factory, your entire career? Let's cut through the hype and get right into it. Think about that for a second. That sounds like something straight out of a sci-fi movie, right? A machine that knows it's about to fail and then schedules its own repair? Well, that's not science fiction anymore. That is Industry 4.0, and it's happening right now. So to really get a handle on this whole self-fixing factory idea, we've got to look back. Because this isn't just another small step forward. No, this is a massive leap. Let's do a super quick trip through industrial history. So it all started with Industry 1.0, steam power, mechanization. Then came 2.0, electricity, the assembly line, mass production. A huge deal. Then in the 70s, we got Industry 3.0, computers and the first wave of automation, a robot on the line. Each one was a revolution in its own right. But this fourth one, this is where things get really wild. We're talking about cyber-physical systems. This is the moment the physical world and the digital world literally merge, and our factories finally become truly smart. So, what it really boils down to is this. Industry 4.0 isn't just about another robot or a faster machine. It's about creating a single, intelligent ecosystem where everything, and I mean everything, is connected, communicating, and making smart decisions all on its own. Now, this is probably my favorite way to think about it. A traditional factory is like a bunch of really talented musicians all playing in separate rooms. They're good, but it's just noise. Industry 4.0 brings them all onto one stage, gives them the same sheet of music, and turns them into a symphony orchestra, all connected and adapting in perfect harmony. It's a total game changer. So how does this orchestra actually make music? Well, it's not just one magic wand. It's really about a whole set of incredibly powerful tools that, when you bring them all together, create this amazing transformation. First things first, you've got the foundation, the Industrial Internet of Things, or IIoT. The easiest way to think about this is as the factory's nervous system. It's this huge network of tiny sensors connecting every single piece of equipment, letting them all talk to each other constantly, in real time. Okay, so if the IIoT is the nervous system, then you gotta have a brain, right? And that's where AI and machine learning come in. This is where the data from all those sensors gets turned into something incredible. The system doesn't just see data, it learns from it. It spots patterns a human engineer never could. And as this engineer from Siemens said, it can predict failures and slash downtime by almost half. And this leads to one of the absolute coolest tools in the entire kit, the digital twin. I mean, just imagine having a perfect, living, breathing virtual copy of your entire production line on your computer. You feed it real-time data from the factory floor, and then you can mess with it, test out new ideas, try to break things, and find the absolute best way to run things, all without any risk to the real equipment. It's the ultimate engineering playground. And believe me, the toolkit just keeps on growing. You've got big data analytics to find the signal in all that factory noise. Cloud computing gives you unlimited brain power from anywhere in the world. Augmented reality can put digital blueprints right in front of your eyes while you're working on a machine. And of course, 3D printing to create custom parts whenever you need them. It's an incredible arsenal. All right, so that all sounds amazing, right? Almost too good to be true. So let's talk about what's actually happening out there in the real world. Let's look at the incredible results and the tough challenges that people don't always talk about. Let's start with the money, 122%. That is the insane difference in positive cash flow between the companies jumping on this early versus the ones lagging behind. We're not just talking about a small advantage here. We're talking about a massive, game-changing lead. And what does that mean on the actual factory floor? How about this? Cutting machine downtime in half. Just think about that. For any operation, that is a staggering boost in pure efficiency. That's money in the bank. Okay, but this one just blows my mind. Harley-Davidson. They used these exact principles and took their custom-built order time from 21 times days down to just 6 hours. I mean, let that sink in. That isn't just an improvement, that's completely rewriting the rules of what's even possible. But, and this is a big but, let's be real, this is not as simple as flipping a switch. You're talking about huge upfront costs. Integrating all this shiny new tech with your 20-year-old systems can be a total nightmare. Finding people with the right skills is tough. Cybersecurity is a massive, critical risk, and sometimes the biggest wall you'll hit is just plain old human resistance to doing things a new way. So, with all that on the table, the incredible upside and the very real hurdles, what does this all mean for you, for the engineer on the ground? How is your actual day-to-day job about to change?
Well, your job is fundamentally flipping on its head. The old way, you were a firefighter. A machine breaks, you run in with your tools, and you fix it. The new way, you're a fire marshal. You're using data to see the smoke before there's even a fire. You're not just managing machines anymore. You're collaborating with intelligent systems to stop problems before they can even start.
And hey, don't just take my word for it. Look at the numbers. Demand for basic physical skills is dropping fast, but look what's skyrocketing. Tech skills like data analytics and those complex cognitive skills, strategic thinking, creative problem solving, the stuff that only a human brain can do. This isn't just a friendly suggestion anymore. Upskilling is about career survival. Okay, so you're probably thinking, where on earth do I even start? And that's fair. It can feel like trying to climb a mountain. But you don't climb a mountain in one giant leap. You start small. Pick one single thing, your biggest, most annoying pain point, and start a small pilot project there. Get your data collection right first, and then invest in yourself. Get trained, and don't ever be afraid to bring in experts to help. So, I'm going to leave you with this one question. This revolution is happening, with or without us. The engineers who are going to build the future are the ones who look at this massive wave of technology not as a threat, but as the most powerful toolbox they've ever been handed. So what's the one small thing you'll do this week to get started? Your journey is waiting.